Mercury is a strange planet in our solar system. Mercury's surface is a barren, rocky environment. It's been hit by rocks from space throughout its history, forming craters. Because there's no atmosphere, no plants, there's been no weathering of those craters, so they're very visible. You also see massive cliffs on Mercury, huge cliffs, many kilometers tall, and those cliffs were formed as Mercury shrank. We call them wrinkle ridges.
Hey there, space enthusiasts. Get ready to blast off into the cosmos with us. Welcome to Spaceverse, where the universe is our playground and curiosity knows no bounds. Join us on an interstellar adventure as we dive into the depths of space, uncovering its mysteries and marvels. From the secrets of black holes to the landscapes of alien worlds, we're here to ignite your imagination and expand your cosmic horizons. With mind-blowing visuals, expert insights, and the thrill of exploration, Spaceverse is your ticket to the ultimate cosmic journey. So strap in, hit that subscribe button, and let's embark on an epic voyage together into the vast unknown of Spaceverse. Mercury is still the planet where we have the least amount of information, despite the fact that it is the planet that is closest to the Sun. This is a realm that is shrouded in mystery, and its neighbors frequently obscure its existence. Is it possible that everything we thought we knew about Mercury isn't actually true? A new body of evidence suggests that the Earth is significantly more dynamic and complex than was previously believed. Each and everything that we believed we knew about Mercury is being called into question, from landscapes that are getting smaller to blue troughs that have no explanation. Imagine a planet that is whirling around the Sun at such a dizzying speed that it is impossible to get away from the solar furnace from where it is located. Only a handful of missions have journeyed to this intriguing world, and even those have only managed to unravel bits of its mysteries. Despite this, it is anticipated that the upcoming expedition known as BepiColombo will shed light on scientific mysteries that have been around for a long time. Our world is already being plagued by occurrences that are unpredictable, peculiar characteristics, and clues that point to a story that has not yet been told. There's a lot more going on with Mercury than meets the eye, according to its X-ray auroras, fluctuating geography, and mystery core. Among the innermost planets, Mercury is the one that is closest to the Sun. A single orbit of the smallest planet in our solar system, which is only marginally larger than the Moon, takes only 88 days on Earth to complete. As a result of its proximity to the Sun, Mercury experiences temperature extremes, with daytime highs reaching 800 degrees Fahrenheit and nighttime lows reaching -290 degrees Fahrenheit. Its topography is a mosaic of hills, depressions, and flat areas all throughout its surface. The absence of an atmosphere that would typically protect the planet from meteoroids is the reason why the surface is covered in craters, giving the impression that it is similar to our Moon. One of the most gigantic impact craters in the solar system is the Caloris Basin, which stands out amid the other meteor impact craters. This vast basin, which has a diameter of around 960 miles, was formed as a result of an event that occurred early on in the history of Mercury. In addition, Mercury stands out due to its enormous core, which is responsible for around 85% of the planet's overall radius by itself. A magnetic field that is just 1/100th as intense as the one that exists on Earth is produced by a core that is rich in iron. Mercury possesses a magnetosphere as well as magnetic poles, despite the fact that its magnetic field is weak. As a result of its interaction with the solar wind, phenomena such as the recently discovered X-ray auroras are brought about. When it comes to exploring Mercury, there are a lot of significant barriers to overcome. Because Mercury is so close to the Sun, any spacecraft that is bound for the planet must be able to withstand the intense heat and radiation that the Sun emits. Furthermore, due to the quick orbit of Mercury, entering its orbit requires accurate maneuvers that require a significant amount of energy commitment. Mariner 10, the first spacecraft to ever visit Mercury, was launched by the National Aeronautics and Space Administration in 1973. It was between the years 1974 and 1975 that Mariner 10 was able to complete 3 flybys of Mercury with the assistance of Venus' gravitational pull. Through these flybys, the surface of the planet was captured at a level of detail that had never been seen before, exposing its intricate geological characteristics and heavily cratered topography. In the photographs taken by the spacecraft, it appeared to be rather similar to our own Moon, with vast plains and a great number of impact craters. Furthermore, due to the fact that the expedition was only able to picture 45% of the planet's surface, a significant chunk of the planet is still unexplored. The basis for subsequent investigations was supplied by the data obtained during the expedition, despite the fact that the coverage was limited. Soon after, in 2004, the United States National Aeronautics and Space Administration (NASA) launched the Messenger mission, which was the first spacecraft to circle Mercury. A rigorous journey that included flybys of Earth, Venus, and Mercury was ultimately completed in 2011 when the spacecraft arrived at the orbit that it had been designed to reach. During the course of its mission, which lasted for 4 years, the Messenger spacecraft conducted more than 4,000 orbits around the Earth. This gave it the opportunity to collect a substantial amount of data regarding the composition of the surface and the magnetic field of the planet. The Messenger spacecraft was able to map almost the entire surface of Mercury, uncovering details that had not been seen before. Tectonic activity signs from the past were displayed, as well as the thin exosphere of the planet, volcanic plains, and other features. In spite of Mercury's close proximity to the Sun, one of the most surprising discoveries was the presence of water ice in craters located in the poles of the planet that remained shaded throughout the whole investigation. Continuing the history of the successful Mariner 10 and Messenger missions, the BepiColombo project represents a significant step forward for the investigation of Mercury. The mission is being carried out in collaboration between two space organizations, one of which is from Japan and the other from Europe. BepiColombo is scheduled to launch in 2018, and it is anticipated that it will collect a substantial amount of data regarding the history, geology, atmosphere, and magnetosphere of Mercury. BepiColombo is comprised of two principal spacecraft: the Mercury Magnetospheric Orbiter (MAO), which was constructed by the Japan Aerospace Exploration Agency (JAXA), and the Mercury Planetary Orbiter (KISA). These satellites will be able to provide a more comprehensive picture of the history of the Earth as well as the current state of environmental change if they combine their data collections. During the lengthy and difficult journey to Mercury, there will be a significant number of gravity assist technologies that will be utilized. BepiColombo made a pass over both Earth and Venus earlier in the year 2020, as well as again in the years 2020 and 2021. It will enter the orbit of Mercury in December 2025, after having completed 6 flybys of the planet previous to that time. Performing these flybys is essential in order to alter the trajectory of the spacecraft and slow it down to the point where it can be captured by the gravitational pull of Mercury. The purpose of BepiColombo is to achieve very high goals. Included in the objectives of the mission are the creation of a comprehensive map of the planet's surface, the investigation of the planet's composition, and the research of its magnetosphere and magnetic field. Furthermore, it will conduct an investigation into the exosphere of the planet in an effort to discover pieces of information regarding the tectonic and volcanic history of the planet. In order to shed light on Mercury's historical development in Genesis, as well as its mysterious magnetic field, the purpose of comparing the data obtained by the two orbiters is to do this. Since its launch in 2018, the BepiColombo spacecraft has been making its way toward Mercury, carrying out a series of flybys that have already resulted in significant outcomes. The preliminary observations that have been made have revealed new information regarding the dynamic environment and complex geology of Mercury. In addition to being a significant achievement, the mission was successful in mapping the surface of Mercury in its entirety. During its mission, the spacecraft discovered a great number of craters that had not been discovered before. Each of these craters offers a different perspective on the turbulent history of the planet. Among these features are impact basins, which not only disclose the remnants of collisions that have occurred in the distant past, but also provide insight into the turbulent early stages of the solar system. Intriguing X-ray auroras detected all around the world are one of the most remarkable findings of the project. The auroras on Mercury, in contrast to those on Earth, are only visible in the X-ray range. The BepiColombo mission has confirmed what the Messenger mission had hinted at. These X-ray auroras are produced when the solar wind, a current of charged particles released by the Sun, interacts with Mercury's magnetic field. A small but scientifically useful glow is produced when these particles smash with the surface of the planet, releasing X-rays. Both the existence of a magnetosphere and the characteristics of Mercury's magnetic field, as well as its relationship with the solar wind, are illuminated by this finding. The fact that Mercury continues to decrease in size is just another significant discovery that has been made during the past few years. In high-resolution photographs, lobates, carps, and wrinkle ridges are examples of the characteristics that are formed as a result of the compression of the planet's crust as a result of the cooling and hardening of the structure's core. These results add to the findings that were discovered by the Messenger mission and make the continual geologic activity that occurs on Mercury more tangible. Because of the compression of the planet's radius, which is contracted by many kilometers since its birth, the surface of the planet is characterized by ridges and cliffs. These stress cracks were caused by the compression of the planet's radius. The BepiColombo spacecraft has discovered many locations where this contraction is most pronounced, which has opened up a fresh window of opportunity for us to see the geology of the planet happening right in front of our very eyes. By examining these regions, which also provide information about the cooling history of the planet, scientists are able to gain a better understanding of the interior structure and thermal development of Mercury. Due to the fact that its surface is so extensively cratered, Mercury appears to be rather similar to the Moon at first glance. Both of these objects have been in close vicinity to comets and asteroids for a considerable amount of time, as evidenced by the presence of numerous impact craters. There are, however, discernible differences when one examines them in further detail. Mercury, in contrast to the Moon, is characterized by the presence of fault scars and ridges among its multitude of craters. In spite of the fact that the Moon does not experience compression, these scars demonstrate that Mercury has occurred. Because some areas of Mercury's surface contain fewer stones than those on the Moon, it is possible that Mercury has undergone geologic processes that are distinct from those of the Moon. Initially discovered by the Messenger mission, Mercury's depressions are among the planet's most mysterious features. These irregular, shallow depressions, often surrounded by luminous halos, have puzzled scientists since their discovery. Originally, researchers thought they might be formed by volcanic activity, but the distinct shape and lack of volcanic features suggested otherwise. Current theories propose that sublimation, the direct transformation of solids into gases, is responsible for these formations. Volatiles beneath Mercury's surface likely sublimate, causing surface erosion and creating sinkholes and luminous halos. Despite Mercury's proximity to the Sun, these findings indicate that volatile substances exist just below its surface. This ongoing sublimation and the formation of depressions suggest active geology on Mercury. Surface measurements of sulfur, chlorine, sodium, and potassium reveal volatile-rich layers several kilometers deep, challenging previous assumptions about Mercury's composition. Sublimation depressions, which are depressions with a flat bottom and a dazzling interior and halo, have been discovered on Mercury. These depressions provide evidence that volatiles are present beneath the surface of Mercury. Surface erosion, which is caused by the sublimation of volatile substances, is the cause of the formation of these pits. This continual geologic process, which suggests that the element is still emitting volatiles, is significantly altering our understanding of the geologic history and current state of Mercury. An amazing phenomenon in and of itself, the sodium tail of the planet is the outcome of this process. The fact that Mercury leaves behind a trail of sodium atoms suggests that it is comparable to a comet, as evidenced by observations. Mercury's surface is the source of this phenomena, which is caused by radiation and the solar wind, which propel sodium atoms into space. The sodium tail, which extends into space for millions of miles, is a good example of a persistent emission of volatile compounds from the surface of the Earth at a distance. Our knowledge of Mercury's exosphere and the mechanisms that generate it has been significantly enhanced as a result of the fact that the tail may be observed with specialized instruments, despite the fact that it is too small for the human eye to detect. Comparisons have been made between the volatile concentration of Mercury and the Atacama Desert in Chile, one of the planet's harshest environments. Despite environmental differences, both regions contain significant amounts of volatile salts and other substances. The Atacama Desert's high salt content and extreme dryness support uncommon extremophiles organisms thriving in hostile settings. Studies suggest similar ecosystems may exist beneath Mercury's surface, characterized by volatiles and salts, potentially supporting microbial life under severe conditions. The survival of extremophiles in the Atacama Desert, despite its salinity and dryness, indicates possible similarities with Mercury. These bacteria's adaptation to minimal water and high salt conditions suggests Mercury might also support life. Mercury's volatile-rich subsurface might meet the necessary conditions for microorganisms. Halides and other salts can undergo deliquescence, absorbing moisture from the air and turning into liquid water, potentially creating microbial habitats. Ever since its discovery, the origin of Mercury has puzzled scientists. Conventional wisdom suggests it originated near its current location, but new research supports the idea that Mercury may have started its orbit much farther from the Sun. This theory, known as planetary migration, argues that gravitational interactions caused significant changes in planetary orbits during the early solar system's evolution. Mercury might have drifted inward from a volatile-rich outer region. Mercury's high density and enormous iron-rich core lend credence to this theory. Recent research estimates that Mercury's core accounts for about 85% of its radius, the largest of any terrestrial planet. Astronomers believe that Mercury was once much larger, similar in size to Mars, and suffered a catastrophic collision with another large planet. This impact likely stripped away much of its outer layers, exposing its deep core and thin mantle. Geologic evidence on Mercury, such as the Caloris Basin, one of the largest impact formations in the solar system, supports this collision theory. Similar impacts are believed to have influenced the Moon and other planets, suggesting a pattern in the evolution of Mercury and the solar system. The discovery of bonanite, a rare volcanic rock with high magnesium content, on Mercury is intriguing evidence of the planet's volcanic history. Bonanite typically forms in extremely heated and pressured settings. Similar rocks have been found in Cyprus, supporting a common production mechanism. The white color in photographs is due to Earth's oxygen-rich atmosphere oxidizing the bonanite. These Earth-like features shed light on Mercury's volcanic history and suggest significant mantle cooling and differentiation. Ancient tectonic processes likely melted oceanic crust and transported it deep into the mantle, forming bonanite. This evidence indicates that Mercury has experienced serious geological activities, including potential large impacts and migrations. Mercury's geological features, such as fault lines, ridges, and volcanic plains, are similar to Earth's, providing insights into the planet's origin and evolution. Despite its small size and proximity to the Sun, Mercury has a complex and dynamic geological history. Studying Mercury helps us understand the development of rocky planets in our solar system and the planet's past. Scientists are eagerly anticipating the massive amount of data that BepiColombo will offer as it nears its destination. Accurate surface maps, research into Mercury's magnetic field, and fresh insights into the planet's geologic past are all goals of the project. Even though it's highly improbable that life exists on Mercury, the finding of volatiles and possible subterranean habitats opens up fascinating possibilities. Life on Mercury may be comparable to that on Earth, where extremophiles flourish in extreme conditions, provided that the planet meets certain criteria. Mercury is one of a kind in the field of planetary science. When looking at the solar system as a whole, this planet is crucial for understanding how the terrestrial planets have changed through time. Research into it sheds light on the mechanisms that have molded our solar system and, by extension, all solar systems. With each passing year, new information about the cosmos and our role in it is revealed, and Mercury is sure to continue to be in the front of scientific investigation. A heartfelt thank you for being here with us today as we come to the end of our journey at Spaceverse. Your support is what drives our investigation of the cosmos. Remember to hit the notification bell and subscribe to our channel so that you can continue to explore with us. See you until the next time we cross paths in the cosmos.